Hi everyone, and this is the real-time data analysis. Today we'll look at this Kaggle competition for bike sharing prediction. Here is the description of it. So we will need to predict how much bikes will be rented for particular date. So let's look at the data here. Okay, so that's sample submission, we will need it later. Now let's look at the training set. Let's download it. Okay, and let's put it to the path here. Okay, so what I have in this path, I have this make JSON file, which is from fast benchmark Telegram bot. It will make the structure of my file, so I will send it to the bot and get the report, something like this. That will help me a lot, so I will not need to do all this preparation, pre-processing and so on. So I will deal with data only with data analysis, data science and machine learning. So what I need to do is to define what I want to predict, and this is sorry, we need to select all. Let's look at those columns, and we have this count. That is how many bicycles will be rented. So this one we will predict, and as you know, we need to form the structure. If you don't know how to work with fast benchmark, you can visit its site. It will be under the video, and there is a video instruction of how to use it. So let's go, say make JSON.py count, and the CSV was train.csv, so train.csv. Okay, could not find it. No count in file. Okay, so no count in train.csv. No count in train.csv. Yes, that's count. Okay, so we are done, and here we are. We have this count structure, and let's send it to the bot. Okay, and here we have the report which we will work with, and to do so we need to run Jupyter lab here. Okay, so here we are, and let's open this one. So here is the generated report which will help us. Let's go read the data, look at that data, and a pair plot here which will show us all the variables and the connections between all those variables. It will take time. Now it's done, so we can see all the variables in this dataset compared to each other. If it's too small, we can do double click here and it's larger, so we can look at this. Okay, so this is how the data is structured, and here are the functions to work with the NA values for numeric NA and categorical NA. So numeric will be replaced by mean, and categorical will be replaced by -1, because we decode categories from 0 to the number of categories, and for none we will use just this -1. Okay, so let's check if we have some some NA. So let's look at this train dot is NA dot no okay, let's look like this first. So we have the same training set with falses on each place their NA values are, so we need to take values, and as false is 0, so we can just take sum, and we will see for each column how much NA we have. Let's look at this. So we have 0 NA in each column, so we don't need actually to work with NA in train. Let's check if we need to work with NA in test. So the same for test. Okay, and run. Okay, so we don't have any NA values in our training test sets. These training test sets were made from this train CSV, so we will train our model on the part of it and test it on the another part. So 80% are on training set and 20% on test set, and here is the instructions about how to change it and so on. Okay, so we don't have any values and we can go further. So let's just go. Okay, so this is our target column. Let's do some pre-processing here. So okay, and let's look at statistics for that column. As we see, this is a pretty large difference between minimum and maximum. Let's look at the distribution. So the distribution is far from normal, and actually Fast Benchmark mentioned that, and it offers us to do the log transformation that will make our predictions much better. Okay, let's do, and that's look much closer to normal, not really normal but closer. Okay, so the next variable is date time, and from now we need to check if those variables are on real test set, not in our splitted test set, but in real test set, because after we will work on this model we will try to build the prediction for all of those. So let's look if date time is in test set. This is the real test set, so we have a date time here, so we can use it. Let's use it. Here we will generate some features like year, month, week, and so on. As we can see, even we can see here, for example, on this head. So how does it look like? So it have years, month, day, and hour, and minutes and seconds are 0. Always 0, maybe not. We'll check it. So okay. So we will extract all those things. Also we will extract weekday, month, day, and the week of the year. Maybe that will be also useful. Let's do that. Okay, here's some description of what is what. And let's look at the statistics for those variables. So here is the distribution of our target variable count for different years. So it's pretty same, but there are some differences that could help us in our model. But there are only 2 years, so I don't think we need some further feature engineering for years. Let's go for months. And for months, let's look at this. Okay, so for some months, which is for month number 7 is July, we have pretty different from others, and August is also closer to July than to other months, and somehow October, so months maybe will be pretty useful. Let's look at the other data. Okay, so let's look at the week, which is the week of the year. So there are a lot of different weeks in the year, and we can see that for week 3 we have some different distribution for some reason, and really for different weeks there are different distributions, so week could be also useful. Let's look at the other data. It's it was months. Okay, so it was month from number 3, which is March. So let's look at weeks, and then weeks. And weeks we have pretty same. So that's some strange week. We have only few, very few count here and here. Maybe something goes wrong on those weeks. I don't know. But maybe we will work at this later. But actually they have only 2 years. Weeks are not so important. If we will work with those weeks hard, it could make some overfitting, I think, because too small values on each week. So let's go to weekday. Okay, so here is weekday, and we have weekday 0, which is actually Monday, and weekday 6 is actually Sunday, I think. Yes. So the distribution by weekdays is really very same, so that's, I think, will be useless. Okay, for months and hours. Okay, so what we have for months? Okay, so the distributions are pretty same, but the numbers are different, so maybe that will help. And for hours we have a really different distribution, so I think ours will be the disruption feature here, because that really it can predict it really well. So as you see, these dead hours we have from 1 o'clock to 5 o'clock for sure. So that is really important feature. Let's go to our 2 minutes. Or not to that was monthly. Yeah, yes, that's ours. We just looked at it. Sorry. Okay, so let's go to seconds and minutes, and that's nothing to show here. So because as you see, length is more than one. Only in this case we will print it out. We will make these histograms, because if it have only one value, it will give us no information, and we'll also drop it. Okay, so let's look at the season. So season is categorical, and this distribution is pretty same. And here is the distribution of our count variable for different seasons. As you see, season 1 have difference, so it maybe will be useful. Okay, let's go to holiday here. Oh, it is no holiday and so small amount of holidays. So let's look at the distribution on different of holidays and non-holidays. So that looks pretty same. Of course, there are so small amount of holidays, that's why it's too small amount of count here, but the distributions look pretty same, so that's not very important. So for now, the most important data we took from the date time, and it was an hour, so the hour variable is very important. Okay, so let's go to the we forgot to check if we have this holiday variable in tests. Let's look at season and holiday variables. So we have it. Good. So next in test set is working day. Let's look if we have the same. And yes, we have the same. It's working day. And okay, let's look. The distribution is pretty same, so that holiday or working day is actually the same. It's just reversed holiday. Okay, so we have a weather. Let's look at the weather in training set. Yes, we have this one. Let's go to this variable, and what we have here, have 4 categories of weather, and let's look at the distribution of count for different weathers. So weather could be useful, I think, because we have pretty different for weather equals 1. And let's go to temperature. So let's also look at what weather is. So weather is 1. Okay, so it's clear weather 1, and the others is light snow, heavy rain, and so on. And of course at heavy rain, this number 4, as we can see, it's really close to nothing. And actually, if we could measure our count variable at the weather equals 4, which is heavy rain, we could see here a large 0. So maybe we can use it in our prediction when we will work with test set instead of splitted train set. We will look at this because we can't learn our model on this because there is no data on this type of weather, and when we will build a prediction model for a real test set, we will need to check if there are some values of the weather like this one, and maybe we will just say that count equals 0 on this type of weather. Okay, so let's look at the other category. It's numeric and it's temperature. Let's look at the temperature in Celsius. Okay, we have it in test set. Great. Let's go. So the temperature is pretty normal distributed. So let's look at its statistics. Okay, so the minimum is near 0 Celsius and the maximum is near 41. It's really hot. Okay, let's go and let's look at the correlation with our count variable, because those both variables are numeric, so the correlation could help us, but this is too low correlation, and here we will check it, and if it is pretty high we will print it. I mean, we will make a plot, a chart with it, but we won't, because that's really low. Okay. And maybe a logarithmic transformation for temperature will be useful, but no, I think that will be useless, and actually our model will not. Actually, if we have this one, it will not use this one, and if you have this one, it will not use this one, because it will give the same results. So maybe it will took this or this, so that doesn't matter. Okay, so now this a temp, what is this? This is feel like temperature. Okay, feel like temperature, and we have it in our test set, so we have to look at this. Okay, so on this a temperature is also close to normal, but we have this little problems here, so let's look if the transformation will help us. Okay. So the correlation again is small because it's actually very close things, temp and day temp. Okay, so correlation is low, but and here again logarithmic transformation is not very useful, but it's not a problem. We have pretty much data, so our model will choose which one it will want to take. Okay, humidity is next variable, and do we have it? Yes, we have it in test set. Let's look. Okay, so it's relative humidity. Let's look at this distribution again, not bad. So the humidity is from 0 to 100. Okay. Let's look at the correlation. Correlation is really low, and maybe log transformation. Okay, the same. So the wind speed now. So the wind speed is here. We have it. So it's wind speed is wind speed. Okay. Let's go, and the distribution here is really far from normal, so maybe here transformation will be useful. Let's look at the correlation. It's super low. And let's look at the log transformation. So it's this 0 here. It's because we have mostly very low wind speed, and here is the other part of it. Okay, so now we see this casual variable. Let's look what is it. The casual is number of non-registered users rentals initiated, but we don't see that in the training, is in the test set, so I think we should just drop this one. So we will we'll say, sorry, where is it? Oh, here, yeah. Okay, no casual in test set will drop it. Okay, let's just delete all those, and actually we need to drop it anyway, so we will put it here just after we found out which column is it. Okay, so we dropped it, and what else? And we need to crop, to cut all of these things. Okay, so register it again. No registered in test set, so we need to do the same here. So no registered in test set. We'll drop it. Okay, so let's do the preparations to drop it, and we need to go here. and oops, and to drop it here, yeah, and delete this and cut off those. So let's run. Okay, so this one, cut, 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 cut. So now we will remove all the columns which we want to drop. Okay, so I'll have this prediction model. We will form it, so let's try to make the prediction of the data as it is. It will take some time. Okay, it's done. So we have this feature importance, and as we said, this date time hour is really important. And what is for humidity? Humidity is also important, and temperature, and so on. Weekday is also pretty important. Month, week of the year maybe. Okay, and let's plot it out. And okay, so the squared log error is pretty low here, and we are really close to real values here. Okay, so what we can do else? Let's look at all those things again, and as we remember, we will try to find out how much weather of type 4 in real test set, and make the prediction for it to 0. Okay, and what else we can find from this data? Maybe we can do something with hours, but I don't really know what. Okay, let's look at the hours. So that's, I think, let's look what is the prediction for these hours. Let's look at this. Maybe we can find out something interesting. Let's say sorry, we need test targeted, our part of test variable which is target for target is test target. So let's find out which is test target for test date time hour equals 1, for example. Let's try. Oops. Oh, sorry. Yes, and so it's pretty low. It's pretty low. But what if we will say that all those let's look at 4. Yeah, also pretty low. Let's maybe assume that what if we will say, okay, let's say like this. I think it will work, but I'm not sure. Okay, it's 1, 2, 3, 4. Oh, it can work like that. Okay, so let it be 1. Okay, so let's try to put our test prediction here to 0. So we will say that we, oh sorry, not this one, but I mean target target. So we saw that that all is was really low by the data, so let's say that it all will be 0, and let's see if our battery can, okay, if our prediction is good. So let's that's not the target, that's spreads. Okay, spreads, spreads are like 0. And let's run this. Oh yes, of course not spreads, but tests here, but for spreads it will be spreads here. So what we want to do is to find which data in our test set in column daytime hour equals 1, and we'll find the predictions for that, and we'll say that the prediction equals 0. Let's try it. Oh, t-preds, we don't know t-preds. Okay. So let's look. Oh, the error is much more now. So that was not a good idea to do so. Okay. So maybe we can just say it will be MP mean for that category in target. Yes, so that will be target, sorry, not target, but train, we need values from what? From train count, and from those values we will take only the values on which train daytime hour equals to 1, and okay, and I don't know if we will need to say values or no, and let's try it only for with this one first. Okay, I think we need oh, we don't have count in train because that's all in target variable. Okay, so let's try again. Oh, of course, data hour is not equals to 1. This should be equals to 1. Okay, so we have again, that's not the good score. So, oh, sorry, we need to predict. Okay, so here is the score, but we had better without this transformation, so we will not use it. So okay, let's run, and look at this, and this score is better. Okay, so now let's just make the prediction on these test values. So let's download it and put it to our path, and what we need to do is to we can't use it anymore because we will not have test target because count is not in test anymore, so we need to make a submission instead of that. And to make submission we need to what is the shape of submission? It's date time, so it's from test. We'll take test date time and count. So, but first let's read it. So now we will not do this train test split. We will just say that this one is train and the test is test, and no train test split anymore. Okay, let's just move on this data. Oops. We have some. Oh, we don't have data, of course we don't need to check these. And okay, so we have train. Oh, we have train again, which is not correct. So it will be test. Okay, let's look. Okay, and do this all. Maybe something will change in this pair plot, which show us the connection between the data. So it's actually the same. Okay, let's go. So again, no none. Oh, yes, again, no none values. Don't need none functions. And let's go here. The statistics of count. Let's look at this, but I think yes, it's pretty same. Let's look at this. Oh, okay, so it was 4. And what we wanted to do is to look at weather here. Okay, so this will just leave the same. This season is the same, holiday the same, working day the same. Yeah, it's just reversed holiday, nothing interesting here. And for the weather, so again we see we have nothing for weather equals 4. Let's just check it out. So what is in training, in which training weather equals 4. Oh, train, not train. Train. Okay, so we have 0 rows. And what is in test? Oh, again 0 rows, so that will not make our prediction better, so we actually will not use it at all in our prediction. Let's go. Okay. So here is temp, pay temp, and so on. That's not important. Okay. Humidity and wind speed. Okay. And this one, no casual, no registered, and remove. And here we will make a model. Let's look at the feature importance. Again, ours is important. Okay, no problem. And what we want to do now, we want to make the prediction instead of this one because we don't have test target here. So let's say that sub, which is for submission, is the PD data frame. How it looks like, it will be like, what is the first one? The first one is date time, so date time is test date time. We actually can't take date time from test because we dropped it, because the XGBoost can't work with data since itself. It only will work with generated features out of data, so we will need to take it on the beginning, on the top there. Let's remember that. So after this we need to make our count. Yes, count is threads. So now we will just write it into the the CSV to CSV submission dot CSV index equals false, because by default it will write it with indexes, and here we have no indexes in the sample submission. And what we have to do is to say what is this column. So here, right after we read the test, we'll say test date time equals test date time. Okay, and let's just restart all of this. It will take time. We again will look at all the data, and after some time we'll get the prediction. So again, as you see, this all is automatically generated, so what we have to do is to look at this, to try to understand how it works, which dependencies are in data. We can try some hypotheses very fast, and actually at the end we will go to the final model with some score. Of course we can work much more on it, but for video it will be too long. It's already took around an hour. So let's look at this. So something is, oh sorry, not sub but sub. Let's run. Okay, so we have the submission here. Let's put it to Kaggle, say late submission, and okay, I have submission here. Let's try to put it here. Up here. It will take some time. Okay, make. So it have a score of around 0.4. It is pretty large score, but actually we can do one more thing here. We can try one more thing here, because actually why we use so small amount of rounds. Let's try a different amount of rounds. That's also could be useful. And as you see, you can do it just from here. It's only some some symbols to add, and you have a new model, some features to add, and you have new features, and you can look at this, and that all is so easy. No, that will take time. Okay, now it's ready. Let's look at feature importance again, pretty same, and let's make submission. Okay, we have new submission, and we'll put it here again. So submission, and actually let's look here at the date. Okay, so this could be okay. So again, pretty close. So that's 0.4. How it will look on the leaderboard. 0.4 is okay. somewhere here, so it's around 20 in, in first 20, 50, and let's go and at first 250, and there were more than 3,000 participants here, so it's really much better than a half. It's actually better than 10%. It's the best 10%, and it took only around an hour. So if you want to use the same approach, the same instruments, you can just move to fast benchmark. It's fastbenchmark.me. You can see here the video instruction of how to use this, and if you are satisfied or not, please take this short survey. It's Google Forms. It's only this short, so only 4 questions here, so that will really help me to make this project better. Okay, so make data science fun again, and bye bye.